Hello and welcome to Nikolai's genetics lessons, and today we are going to construct phylogenetic tree using this table of traits and species. On your exam you should be able to do it under 2-3 minutes, and you only can do it if you will practice the skill. So let's read the problem. Use the morphological traits shown in the table A to construct a phylogenetic tree. For plants, any style of phylogenetic tree is fine. Be sure to clearly label all the synapomorphies, and here's table A, morphological traits of plants. X stand for the trait possessed by plant. Let's take a close look at our table. So on this side we have 1, 2, 3, 4, 5, 6 species of plants, and on this side we have 6 traits. I want to bring to your attention that green alga here doesn't have any traits at all, so it's clearly going to be our outgroup. And here's going to be the sides of the phylogenetic tree. And green alga, as you see, doesn't have any traits, so we put it here and we put GA, which is going to stand for green alga. One more time, green alga doesn't have any traits which other plants have, so this is going to be our outgroup, and all the rest we are going to plot on this side. Now let's take a look at our table. Next is going to be liverwort, which has cuticle. So this is going to be the only trait that it has, so that means that it have to be at the very beginning here. And let's also put a branch here for the liverwort. So this is going to be liverwort, and L would stand for the liverwort. And this bar here is going to stand for the cuticle. So let me also highlight cuticle here. So this is going to be cuticle. So cuticle, of course, we can find in liverworts, because this is going to be land plant. And green alga doesn't need cuticle, which would protect from losing water, because it grows in the water and doesn't need it. Next, in this table we should look for the plant species that has 2 traits, and one of the trait should be cuticle, just like in liverworts, because we pass this bar, so next species should have this trait. And this is going to be ladyfern, that also has cuticle and also has stomata. So has stomata. Stomata is a small opening on the leaf surface that allows plants to breathe, actively exchange gases. So we add this trait on this side, and we also put a name that it stands for the stomata. So stomata. And we plot ladyfern here. So this branch would represent ladyfern. So L, F would stand for this species. Next we are looking for the plant with 3 traits, but there is no such plant here. We have a plant durum wheat with 4 traits and ginkgo with also 4 traits. Let's check those traits. Both of them has cuticle, so they have passed this bar here. Both of them has stomata, and both of them has seeds. So durum wheat and ginkgo has seeds, and we don't have this trait here. So let's put this trait seeds. So let's put it here. So this bar would stand for seeds, and both these species have to be pass this bar, pass all these 3 bars. Durum wheat has flowers, but ginkgo doesn't have flowers. Ginkgo has cones, but durum wheat doesn't have cones. So now our phylogenetic tree would look as follows. So let's add another branch here, and it's going to stand for the ginkgo. Let's put G on top. We also know that ginkgo has cones, which durum wheat doesn't have, so we put cones here. Let's add the name of this trait, cones. So cones. And this also means that this tip of the branch have to be durum width. So let's put it here. So DW would stand for the durum width. And durum width has flowers, which, for example, ginkgo doesn't have. Let's also add a bar here, which would specify that these plants have flowers. So flowers. So according to our phylogenetic tree, for example, durum wheat has all the traits, including flowers, but excluding cones. But ginkgo has all the traits, excluding flowers, but has cones. And now let's check the last species. So as you remember, we start with cuticle. So every plant should have cuticle if it is on this branch. And it does has cuticle, so let's highlight it. Next, it should have stomata, and it does have stomata, so that means that it have to be above this bar. It also has seeds, it also pass this bar, and as you see, it also has cones. So that means the evolution has turned the same way as in ginkgo, and it passed this bar. By the way, synapomorphism means that trait have to develop into the common ancestor, and we do not take into account possibility that traits can develop here independently. So the same trait we would see in different species which develop independently. So we have to assume that all the traits that we can see are due to presence in the common ancestor. If we find such trait in two and more species, for example, cuticle, for example, in durum wheat and in ginkgo, not because they developed this trait independently, but because they had common ancestor, which developed this trait. So as you see, white spruce, we should put here, and WS would stand for this species, but also this species has a new trait which is needles. No any other species has needles, so let's put a bar here which would specify that the species developed needles. So let's put needles here. So we finish our phylogenetic tree, and you may also make different phylogenetic tree which may look something like this, but as far as it shows the same type of relationship between species, it doesn't matter how your phylogenetic tree looks like. And this is all for today. Subscribe and see you in the next video. Goodbye.